Alright, so section 12.4 and 12.5 are about something called the law of sines, the law of cosines. Before we do that, there is one problem that's related to the law of sines, and that's how to find the area of a triangle. So if you look at 21, normally to find the area of a triangle, the formula for that is 1/2 base times height. And there's a proof for why the following formula is true, but basically you can take that and you can rearrange it so that it ends up being this. It equals 1/2 AB sine C. And usually this angle, not usually, always, this angle has to be the angle that's between those two sides. A and B stand for sides, and C is the angle. Okay, so if you look at this, this is the pattern right here. There's an angle. Sorry, that's not an angle, that's a side. There's an angle, and that's a side. So basically you get what's called an SAS, or a side angle side triangle. And all you need to do is plug those values in to solve. So 1/2, there's side A, there's side B, and there is the sine of C, the sine of that angle. And when you simplify this out, 1/2 of 6 is 3. 3 times 13 is 39. So 39 times the sine of 53 degrees, plug that in a calculator, and they tell us to round to the nearest tenth. Turns out to be 31.1. Okay, 22 and following. Basically, when they say solve each triangle, it means find any of the missing sides. And they also talk about something called ambiguous cases. Ambiguous cases is when you can have more than one triangle. That's not going to be possible in this problem, though, because they've drawn the triangle for us. We can only have ambiguous cases if they give us measurements and they don't give us the drawing. And I'll show you how to locate those. Alright, so let's first of all find the missing angle. So we know these two angles. We know 28 and 110. And we know that whatever the third angle is has to add up to however many degrees there are in a triangle. And there's 180 degrees in a triangle. So let's just solve this. So 138 plus we don't know is 180. If we subtract 138 from both sides, we'll get 42 degrees as our missing angle. So let's verify, and that works. Okay, now we can use the law of sines to solve the rest of it. Okay, so the law of sines is this. It's sine of one angle over its opposite side equals sine of another angle over its opposite side, which equals sine of the third angle over its opposite side. So we can pick anything here. Actually, we don't have a choice about this. We have to pick 7 because 7 is the only side they're giving us. Okay, so let's do that. So let's do 7, which is opposite to 28. So we could do the sine of 28 degrees over 7 equals, and it doesn't matter which other one we pick. So let's pick the 42 degree one. So we'll say the sine of 42 over, we don't know. Okay. And I know I labeled it B, but this is a question mark right here. So how do we solve this? Well, again, let's call that X because we don't know it. Instead of using a question mark, we'll say X. We can just cross multiply these. So we'll get 7 times the sine of 42 equals X times the sine of 28. Let's divide both sides by sine 28. And this right here, whatever this is, should be our X value. So let's double check that by plugging it into the calculator, make sure we're in degree mode, and we are. Okay, then we need to do this. We need to do 7 sine 42 over sine 28. So 7 sine 42 divided by sine of 28 degrees. Close that parentheses, we get 9.97, which rounds to basically rounds up to 10, because they said round to the nearest 10. So that means the 42 degree side should be 10, and it is. And then the last one, we just need to set it up again using the law of sines. So we can use either of those two sides that we found. Let's just stick with 28 degrees and 7. So the last one will be sine 28 degrees over 7 equals sine of this angle, because we haven't touched that one yet, sine of 110 degrees over this right here. We'll call that Y. Okay, same idea, we'll cross multiply, so we'll get 7 sine 110 equals Y sine 28. We'll divide both sides of this by sine 28, and Y is going to equal this number right here, which when you plug it in, sorry, that's a 28 by the way, not a 78. It's messy looking too. When you plug that in a calculator, you should end up with, so erase that for a sec, you should end up getting the number 14, at least rounds to the nearest tenth. It might be 13.9 something, rounds up to 14. Okay, again, it says check for ambiguous cases here, but we can't have an ambiguous case because they're giving us the picture. So this is another case of using the law of sines. And if you're not sure what it says, use laws of sines or cosines. If you're not sure which one to use, always try to use the law of sines, and you'll find out pretty quickly whether you can do it or not. So we're going to have to use the 29 side, because whenever they give us a side, that's what you can use. So it's opposite to 65. So sine 65 equals sine of 22, okay, over something we don't know. So over x. And by the way, we also can find that third angle right here, same as we did before. So if we add these together, we get 87. And then if we subtract 87 from 180, we would get 93 degrees. So that third angle should be 93. And it looks right. It looks almost like a right angle there, a little bit 3 degrees more than a right angle. Alright, so now we have all three angles. Okay, sine of 22 over x. Now here's the thing, how would you know if you couldn't use the law of sines? Well, notice we have three places where numbers are plugged in. If you do the law of sines and you're ending up with two variables, you can't do it, because you can't solve something, at least not easily, not in any obvious way. You can't solve it if there's two variables there. So that's how to know when to use the law of sines, when to use the law of cosines. Start with the law of sines. If you have two variables, then you're lacking information. You need to fill in more. So some of the information might be finding that extra angle, which we just did. Okay, let's cross multiply. So we get x times sine 65, and that's going to equal 29 times sine 22. We can solve for x by dividing by the sine of 65. And so x, that unknown side, is going to equal this number right here, rounded to the nearest 10. And that turns out to be 12. Okay, let's get the very last one. So we can use any sides and angles that we want now. Let's just stick with sine 65 over 29 like we did before. And that's going to equal, we'll call this y now, that's going to equal sine of 93, because that's what it's opposite to, over y. So we'll cross multiply, we'll get y times the sine of 65 degrees equals 29 times the sine of 93 degrees. We will divide both sides by sine 65, and when we do that, it should make sense that this y side should be bigger than either of the others, because the biggest angle in that triangle is 93. So that means that should be the biggest side, and it is. It's 32, which is the largest of those three sides. Okay, so now we're going to have to check for ambiguous cases here, because they are not giving us a picture. So we need to draw the picture. And these are always, triangles are always labeled ABC, typically, unless they tell you otherwise. So let's draw this. It doesn't have to be perfectly to scale. Okay, here's the thing to notice too. A, 63. Side A is 20, side C is more than 20. So that means angle C is going to be bigger than 63 degrees. So I'm going to keep that in mind when I'm drawing. It doesn't have to be perfect, but nice to have a decent picture right there. So there's side A, there's side B, there's side C. We know this is 63. We know side A is 20. We know side C is 22. That's all we know. Okay, so we'll try to use the law of sines, because we always try to use that by preference if and when we can. So let's try that. So the sine of this angle over its opposite side, sine 63 degrees over 20, and that's going to equal, well, we only have one other side, so that's one we have to use, and that's opposite to this angle, and we'll call that angle C. I should say big C, so that's already labeled there. So sine of angle C over 22. Same idea as before, we'll cross multiply, so we'll get 20 sine C equals 22 sine 63, and then we'll solve this by dividing by 20. And here's how we can tell if we're going to have multiple triangles, possibly. Okay, we'll tell in just a sec, because there's a couple more steps. First of all, let's find out what that equals right there. 22 sine 63 over 20. So 22 sine 63 divided by 20, and that ends up equaling 0.98. Okay. And actually, I'm going to store that in the calculator. We're using angle C, so I'm going to store that as C. Actually, not quite yet. So the sine of C equals that number. We want to cancel out the sine, though, because we want to find out what C equals. Remember, C is an angle. Okay, so let's find out what C equals. How do you cancel out the sine? And the answer is you take the inverse sine. So those will cancel. We'll take the inverse sine of this. So the inverse sine of that number that we just found, that's going to tell us what angle C is. And the thing is, I didn't actually get rid of this yet, and that's important. I don't want to round it to 0.98. I want to keep it there. So second inverse sine of second answer. The answer is where the negative key is. That's going to take that exact value. So what's nice is you get a more accurate answer that way. It's not going to be rounded. and we get 78.6 degrees. Now we can round safely. So 78.6 degrees. So let's label that on our triangle right here. So 78.6. Okay, and then let's just finish solving this. So 78.6, so if we add these two together, and then we subtract from 180, okay, that's going to give us our third angle. And when we add those together, what is that? 141.6, I think that's 38.4. Let's just double, yeah, that should be 38.4. Okay, let's just find this last part right here, and then we're going to have to check if there's a second triangle. Okay, so the next part should be, let's just use the sine of 38.4 over y, and that's equal to the sine of, let's stick with 63 and 20. So sine of 63 over 20 will cross multiply. Y times the sine of 63 equals 20 times sine 38. Sorry, that's a 38.4. Divide both sides by this, and y is going to equal whatever that number is right there. And let's check to see what it is. So 20 sine 38.4, 20 sine 38.4 over the, I believe it was the sine of 63. It was over sine 63. So let's see what we get here, and y equals 13.9. Get to round to the nearest tenth. Okay, and I mean that makes sense. Y should be the smallest side because this is the smallest of those three angles. Okay, but here's the big thing. How do we find out if there's multiple triangles? So we know for sure that we have a first triangle because we just found it. So here's how I like to do it just to keep it organized. Just label your sides and your angles. So we know that angle A was 63, B we found out to be 38.4, and C we found out was 78.6. And we know that the sides were, A was 20, B was 13.9, and C was, what was C? C was 22. Okay, so that's definitely our first triangle. If there's a second triangle, and this is important, if there's a second triangle, we don't know that yet, but if there's a second triangle, then what's going to be the same? Well, we know for sure, they told us for certain that A is 63. And they told us that the side A is 20 and side C is 22. So we know for absolutely certain that those things have to be in the second triangle if there is a second triangle. Okay, the stuff that I left blank is stuff that we don't know yet. Those three things. Okay, so here's the question: is there a second triangle? When we did this before, when we did this part, this is the key step. This number right here was, I believe it was 0.98 when you plug that in a calculator. So we said the sine of C is 0.98. Here's why there might be a second triangle. If you remember from the unit circle, here's the unit circle. On the unit circle, the x-coordinate is the cosine, and the y-coordinate is the sine. And when we're dealing with triangles, triangles go from 0 degrees over here to 180. Triangles go from 0 to 180, and there's an acronym for telling when each trig function is positive. It's all students take calculus. So notice this, not only in quadrant 1, but also in quadrant 2, sine is positive in both of those quadrants. And this equation is telling us that the sine of C is positive 0.98. So where does that happen? It happens in two places. On the unit circle, remember, unit circle means this is a radius of 1. So that coordinate right there is x equals 0, y equals 1. So where does y equal 0.98? It equals 0.98, a little bit less than 1, so about right there. Okay, that's y equals 0.98. But it also equals, let me use a different color here so you can see a little bit better. Equals 0.98 here, that's that vertical height. It also equals 0.98 right here though. So it actually has two places where the sine is 0.98. We found one of them. One of them was, when we plugged this equation in right here, what do we get for C? We got 78.6 degrees. So we know for sure that's 78.6. Okay, now over here, what is this angle? Because that's the other angle that has a sine of 0.98. And it's going to be, this also is going to be 78.6 degrees. But then the question is, what is this larger angle? I should say the reference angle, 78.6. What is this one? That orange one is the one that matches up with 78.6. And notice, if I were to take this entire yellow angle here and subtract out this 78.6, I would be left with the orange. The whole yellow angle is that 180 degree angle. So let's subtract that and we'll get 101.4, which, if there is a second triangle, that's going to be our C angle. Okay, so I don't want to confuse people. Just to recap how we did that, the whole reason there's a second triangle is because this thing happens in two places. It happens in the first quadrant and it happens in the second quadrant. So to get the other possible triangle, if there is one, we took the first thing we solved for, and that's important. We did not do 180 minus 38, we did 180 minus 78, because 78 is the first thing we solved for. We take 180 minus 78, we get this one, and if there's a second triangle, that is going to be our possible angle. Okay, how do we test if there is a second triangle? Here's how we do it. We basically add these two angles together, and if we do not reach 180, if we get over 180, it's impossible because triangles can't be over 180. If we haven't reached 180, then we know there might be a second one. So this is going to be 164.4. We have not reached 180. That means there is going to be a second triangle. And when you do 180 minus that, it's 15.6 degrees, which gives us angle B. Okay, and then when we do the law of sines, I'm running out of space here. When we do the law of sines, we can just pick any of these. So let's just pick sine 63 over 20 equals, we don't know this, so let's call it x, the sine of 15.6 over x. You would cross multiply like we did before, and you'd solve it, and I'll just show you what the solution is. Okay, so let's make sure we have both. This one right here, okay, you hopefully recognize these were the angles that we found. We found 13.9. We found 101.4, we found 15.6, and then this last part, I didn't actually do it, but if you do the cross multiplication and solve, you would get that second triangle. Okay, so the only way you won't have a second triangle, first of all, they need to not give you a picture. They started out not giving us a picture. That was one that we drew. Okay, is if you do this right here, this is the key step. If you do this and you get something less than 1, that means there could be a second triangle. When you have two acute angles there, which we do, this can result because there's two places where sine is equal to that. Alright, let's try one more, and we don't know yet if there's going to be two triangles or one. So let's just deal with the first triangle first, and we'll label this. Okay, so they're giving us side B is 28, and they tell us side C is 27, and they tell us that's 46 degrees. Okay, and obviously B is a bigger angle than C because its side is longer also. So let's try to draw this as best we can. You don't have to be perfect. ABC, so C is 46, this side is 27, this side is 28, and we don't know this. So let's start by finding what angle B is. Sine of B over 28 equals sine of C, which is 46, over 27. We'll cross multiply. 27 sine B equals 28 sine 46. And we will divide by 27, is that right? Yes, 27. And sine of B equals this number. And then what we want to do is we want to solve for B, which means taking the inverse sine, because that's going to cancel this out. So we want to know the inverse sine of that huge number right there. Not huge number, but messy number. And that's going to give us angle B. And then from there we'll be able to judge if there might be a second triangle. So inverse sine, what did it say? 28 sine 46. 28 sine 46, let's make sure we get the parentheses right, divided by 27, and we get a 48.2 degree angle, which makes sense because C is supposed to be, or B is supposed to be, a little bit more of an angle than C. So 48.6 degrees. So let's fill that in. Okay, now how can we get A? We can add these and subtract it from 180. So 180 minus those added together. What's that? 94.6. So that's going to be 85.4 will be A. Okay, and then we can do the law of sines again. We've done that several times, but just to simply fill this in so we have it. This is 85.4 degrees. When we do the law of sines, we could do sine of that over that. Sine 46 over 27 equals sine 85.4 over, we don't know. Okay, then we would cross multiply. We would do that as we did before, and I'll just show you the answer. A turns out to be 37.4, which makes sense because A is the largest angle there. Okay, question: is there another triangle? Well, let's see if there is another triangle. So it all depends on what this number is right here. We didn't actually calculate that, so let's just calculate what that is. 28 sine 46. 28 sine 46 divided by 27 equals 0.74. So let me show you on the circle that there are two places where 0.74 happens for sine. Here's the circle. The y coordinate up here is 0, 1. Okay, where does the y coordinate equal 0.74? Maybe about right here, roughly 0.74 here, and that means that it's also 0.74 right here in the second quadrant. We found out this angle. This angle is 85.4 degrees, which means this angle, same reference angle, is 85.4. So then what is this yellow angle right here? What is that? It's 180 minus 85.4, and that turns out to be 94.6. Okay, so let me clear some of this off here. Just clear these annotations. Oh, I didn't want to do that. Let's try to undo that. There we go. Okay, so let me just clear off some of this right here. We have more space. Did not want to delete that whole thing though. Okay, if there's a second triangle, and we're not sure yet, if there's a second triangle, we know that these parts were a part of the original problem, so those have to be part of the second triangle. And then when we did 180 minus this, we got 94.6 degrees. Okay, if you add this and this, you haven't reached 180 yet, so you can still go further. Okay, and it turns out that B is equal to, when you add those together, you get 140.6. So that means this would be what's left over from 180. And there is a second triangle there. So, and if I had done it right, it would have made more sense. Let's see what went wrong here. So we got 85.4. For some reason we rounded this, or I rounded it slightly wrong. Let's see what the mistake was though. So 46 is correct for B, 27, 28, those are definitely right. Did we do the wrong, possibly the wrong reference angle here? Let me just check. No, 94. This should be right though. Let me just try to troubleshoot this mistake and see what might have happened here. Okay, I see what happened. So yes, and this is actually a good thing to point out. The first angle we solved for was not, I was treating it like it was angle A. That's wrong. The first angle we solved for was this one right here. So this should actually be 48, and 180 minus, this is 48, 180 minus 48. The reason we have to do that is the way we got A was we got A by first getting B. So when you're doing 180 minus your angle, you have to use the first angle you solve for. Okay, 180 minus 48, I guess it was 0.2. For some reason I mistook this. I must have rounded wrong. 180 minus that is 131.8. So that's 131.8. 131.8 plus that is 177.8. So when you subtract that from 180, that's where the 2.2 comes from. And then you can use the law of sines to get that third side. Alright, so that is up until most of 12.5. In the next video and following, I'll show you, these are going to be, I think, law of cosine problems, so we'll show you how to do that next.